A cluster of tropical thunderstorms can become one of Earth's most powerful weather machines, but only when several fragile ingredients line up at the same time. The first ingredient is warm ocean water. Tropical cyclones usually need sea surface temperatures of at least 26.5 degrees Celsius, 80 degrees Fahrenheit, and that warmth must extend roughly 50 to 60 meters, 165 to 200 feet below the surface. If the warm layer is too shallow, early storm winds churn up cooler water from below and cut off the fuel supply. That fuel is water vapor. Warm seas evaporate quickly, loading the lower atmosphere with moisture. When that moist air rises into cooler air above, the vapor condenses into cloud droplets and releases latent heat. That released heat makes the air rise even faster, lowering pressure near the surface and drawing in more warm, moist air. This feedback loop is the engine of cyclone growth. But heat alone is not enough. The atmosphere must be unstable, meaning air can keep rising and building deep thunderstorms. Humidity must also be high through the lower and middle atmosphere, so dry air does not weaken the storm by evaporating cloud droplets and cooling the core. The developing system also needs a starting disturbance, such as a tropical wave or a broad low-pressure area, to focus the rising air. Next comes spin. Earth's rotation creates the Coriolis effect, which bends winds as they flow toward low pressure. This bending helps a closed circulation form. In the northern hemisphere, tropical cyclones rotate counterclockwise. In the southern hemisphere, including Australian waters, they rotate clockwise. Very near the equator, usually within about 5 degrees of latitude, the Coriolis effect is too weak, so cyclones rarely form there. One of the biggest enemies of a young cyclone is vertical wind shear. Wind shear means winds change speed or direction with height. Low shear lets thunderstorms stay stacked over the surface low, concentrating heat release where it strengthens the circulation. Strong shear pushes the storm tops away from the center, tilts the vortex, separates the heat engine from the low pressure below, and can tear the system apart. If the ingredients stay aligned, the system evolves in stages. It may begin as a disorganized tropical disturbance, then become a tropical low or depression with a clearer spin and falling pressure. When sustained winds reach about 63 km per hour, 39 miles per hour, many agencies classify and name it as a tropical cyclone, hurricane, or typhoon, depending on the ocean basin. As pressure drops further, spiral rain bands wrap around the center. A mature, intense cyclone may form a calm eye surrounded by an eye wall, the ring of thunderstorms that contains the strongest winds and heaviest rain. At extreme strength, Category 5 systems represent the upper end of this heat engine, capable of catastrophic damage. Climate patterns and regional seasons influence where genesis is most likely. Warm ocean anomalies, monsoon troughs, the intertropical convergence zone, El Niño and La Niña, and atmospheric pulses like the Madden-Julian oscillation can all change the odds. The names vary around the world, but the recipe is the same. Deep warm water, moisture, instability, low wind shear, a trigger, and enough planetary spin. Remove one key ingredient and the storm may fade before it is born. Combine them and scattered thunderstorms can organize into a rotating cyclone that reshapes weather across entire coastlines.